Hello everyone. Today we are going to discuss a question of GATE 2022, and this question is of topic topology. So in this question, let x is equals to r and t, where t is the smallest topology on R in which all singleton sets are closed. तो इस टोपोलॉजी के बारे में हमको पूछा गया है कि क्लोज्ड जीरो ओपन वन इज कॉम्पैक्ट और नॉट, एक्स इज फर्स्ट काउंटेबल और नॉट, एक्स इज सेकंड काउंटेबल और नॉट। सो सबसे पहले तो हमको ये टोपोलॉजी देखनी पड़ेगी कि ये कौन सी टोपोलॉजी है। तो जो गेट में जो क्वेश्चंस बनते हैं उसमें बेसिकली 5-6 नॉन टोपोलॉजीज हैं, उसी के ऊपर होता है। उसी में से एक ये टोपोलॉजी है, कोफाइनाइट टोपोलॉजी। कोफाइनाइट टोपोलॉजी को हम डिफाइन कर सकते हैं U subset of R such that U complement is finite. So this is the topology in which all singletons are closed. So अगर हम ये टोपोलॉजी समझ गए कि ये टोपोलॉजी है तो ये क्वेश्चन हैंडल करने में इजी होगा। सो अब आते हैं ऑप्शन नंबर ए पे। ही इज आस्किंग दैट क्लोज्ड इंटरवल 0,1 इज कॉम्पैक्ट इन एक्स और नॉट। सो लेट अस सपोज दैट U alpha belongs to any indexing set is an open cover of closed 0 open 1. Now we have to see what type of open sets is in this topology. So we can clearly see R minus singleton 1 is an open set in this topology. Why? Complement of this is singleton 1, which is finite. R minus singleton 1 2, complement of this is 1 2, this is finite. So these are the open set in this topology. Okay, means R minus any finite set. So this is open set in this topology. Okay, so now we have to show that this is compact. So we considered that U alpha is an open cover of this closed 0 open 1. This implies that U1 is open set in this topology. So U1 complement is finite. So consider U1 complement is x1 x2 xn. Now we are saying that this U1 complement is finite and U alpha is open cover of this. So this x1 x2 xn will be somewhere in this interval, and there is open sets containing this x1 x2 xn. So let us suppose that those open sets are denoted by u x1 u x2 u xn. So what we get, we can clearly see u1 ux1 ux2 uxn is an finite open cover of this closed 0 1. How we are saying this? I am repeating it. We suppose that this U alpha is an open cover of this closed 0 1. Okay, so we considered one open set U1 from this family. So U1 complement should be finite. Why? Because in our topology, open sets or those sets whose complement is finite. So we considered x1 x2 xn be that complement of U1. So already all the elements are in U1 except x1 x2 xn. So what we did, we considered n more open sets containing x1 x2 xn. So we cover all the elements of this closed 0 open 1 such that this is contained in the union of these finite sets. So and these open sets are also in this family. So we find an open cover because we are choosing these open sets from this family. We are saying that this is open cover of this. It means that for every element of this there is an open set containing that. We got an finite subcover of this family. So this option A is true. means closed 0, open 1 is compact in X. Now for second, X is not first countable, and X is second countable, X is first countable. So we have to know one theorem which says that if X is second countable, then implies X is first countable. What is contrapositive of this statement? If X is not first countable, this implies X is not second countable. So if we show that X is not first countable, then option C and D both discard. So for this we have to know directly that this space cofinite space is not first countable. So in exam we can tackle by this way, because solving in exam is very typical process, so we have to know these things for 10 question in exam. So we are now going to show that X is not first countable. So for this we have to show that there exists an element A in R such that it does not have local base. So let us suppose that X belongs to R, or space X. For this uh, we denote a family AX, a family of neighborhoods, a family of neighborhoods of X. Okay, so if we are saying that this AX is a local base of X, then if X is X U is open, any open set containing X, then there exists Bn belongs to this family such that Bn is contained in U. This is the meaning of having local base. So now let us suppose that we are considering Fn, which is defined as X minus Bn, or R minus Bn. Now we define a new set F which contains singleton X and union of all Fn, n belongs to natural number. Now what we are seeing here, Bn is open set. Why? Because this is, we are containing a set of open neighborhoods. What does mean of local base? Means every if we consider any point, then it has a countable number of neighborhoods always. So these Bn's are open. This implies that Fn is closed, and most importantly, this is complement of Bn, so it should be finite. So all Fn is finite, and we are taking countable union of finite set. This implies that F is countable. So F cannot be equals to R, because why? Because R is uncountable. So let us suppose that Y belongs to R minus F. Okay, now define a new set U, which is defined as F, which is defined as R minus singleton Y. Okay, now my question is, U is an open neighborhood of X or not? My question is, U is an open neighborhood of X, small x, this small x, or not? Now clearly we can see that complement of U complement is singleton, means finite. This implies that U is open, and since only the element Y is not in U, this implies that X belongs to U. So U is an open neighborhood of X, मीन्स U एक ओपन सेट है जिसमें X कंटेन्ड है. ओके, तो अब हमको ये सर्च करना है कि क्या इस फैमिली से, जो हमने AX फैमिली डिफाइन की है, कोई ऐसा सेट है सच दैट X belongs to Bn and which is contained in U. This thing is possible or not? If this thing is not possible, then this AX will not be a local base of X belongs to R. So for this we can clearly see that y belongs to y does not belongs to f. Why? Because we are considering y from f complement. This implies that y does not belongs to fn. Why? Because f is union of all these things. If y is not in f, means y is not in this, not in this. So this implies that y is in bn. Okay, we got that for every n belongs to natural number, y is in bn. So if bn is contained in u and y is contained in bn, but y is not in u. Why? Because u is an open set which is defined as r minus y. So we got a contradiction. What contradiction we got? We got that y belongs to bn, means y is here, and this is subset of this. This is subset of u, and in u we know that y is not in u. So this is contradiction. This implies that we considered and countable neighborhood basis for x. This implies that we considered it wrong. So x is not first countable. X is not first countable, so B option is also true. X is second, by that statement, if X is second countable implies X is first countable. Contra of this statement is if X is not first countable implies X is not second countable. So this option is wrong, and we saw that X is not countable, so this is also. So correct option is A and B. Thank you.